Raja from USA, and the Secretary and Correspondent of our M.A.M. College of Engineering, Dr. M.A.M. Nizam, the faculty members of M.A.M. College of Engineering, my dear students and other invitees from various institutions, especially the invitees from Computer Society of India and invitees from BHL Tiruchirappalli, a warm welcome to this special webinar. So on behalf of M.A.M. College of Engineering, I extend a warm welcome to this special webinar on container technology. I think 75 billions of devices will going to be connected to internet. Assume that this 75 billions of devices going to access the cloud lead to n number of challenges. So out of this n number of challenges, some of the challenges will be solved by this type of container technology. I think we have a right person with us to explain what is container technology, how it will be actually implemented in cloud, and everything is clearly explained to this August gathering, to this audience. Okay, so we have an eminent personality from USA. He is my classmate during my BE Computer Science when we study at REC Tiruchirappalli during the year 1993 to 96. So once again, I extend a warm welcome to M. Raja. Raja, welcome you, Raja.
Hey, thanks, Ravi. That was a great introduction. It's been a pleasure meeting you over Zoom after 15 plus years.
Raja?
And, yeah, can you hear me?
My voice is clear? Yeah.
Yeah, your voice is clear. Ravi, can you,
yeah.
I get a message that the host has disabled participant screen sharing. So I don't get why I'm not able to share the screen. Can you double check if I can?
1 minute.
Sure.
1 minute, please.
Sure.
How did I make you as a co-host?
No, I think I only see Niscare app as host and Niscare app as co-host. And I see a Raja M. That's not me. Raja Mani is me.
Raja?
I think Raja Mani. There's an account named Raja Mani. That's the one that you want to give access to.
Raja Mani.
Yeah, Raja Mani. That's my.
Okay, now it's clear.
Yeah, I think now I can share the screen. You're right.
Thank you.
Let me know when you're able to see my screen. Okay, it should be a blank screen now.
Now you can share.
Yeah, I already shared the screen. I'm going to start the presentation. Good evening, everyone.
1 minute, please, Raja.
Sure.
I request Professor Ilango, Department of Computer Science Engineering, to welcome the gathering and introduce the chief guest to this August gathering. Please, Ilango.
Good morning to all. Our college secretary, Honorable Dr. Mohammed Nizam, sir, respected principal, Professor Dr. S. Raviman, sir, faculty members, and my dear students and delegates, my warm welcome to you all to this international webinar. We are very much honored to have an eminent personality and experienced person, Mr. M. Raja. My hearty welcome to you, sir. It is my duty to introduce our guest speaker, Mr. M. Raja, who is proceeding to present a topic today on container technology. Mr. M. Raja is currently Vice President of Engineering, TransPerfect, California, USA. He's joined TransPerfect Interactive Division in September 2011 as Director of Engineering and has been promoted to Vice President of Engineering in May 2017. He has over 2 decades of experience designing, developing, and delivering console, desktop, and web applications using different technologies and programming languages. As the head of the development division, he is responsible for the architecture, design, development, and the testing and DevOps of Transcend. Mr. Raja is a very agile, enthusiastic, and experienced technical leader who is very hands-on when it comes to using the right process and technologies to solve complex business problems. He never hesitates to roll up his sleeves to solve customer issues and always looking to improve the process and quality of Transcend by actively listening to the feedback from sales, CSR, and customers. He is very specialist in Microsoft .NET, web technologies, and have over 13 years of experience in running engineering and IT teams both onshore and offshore. He holds a BSc degree in computer science from NIT Trichy and is a certified Scrum Master and MCSD microservice solution developer in .NET. He actively blogs about .NET and latest JavaScript frameworks in his blog and has a YouTube channel where he posts video tutorials on .NET and Aurelia, a modern JavaScript framework to share his knowledge with the community. His special areas, .NET, Scrum, C#, JavaScript, Aurelia, Node.js, Java, C++, C, Objective-C, VB, OOAD, Solid, Design Patterns, Enterprise Architecture, Web Applications, CFS, Hyper-V, offshore and onshore team building and management. Now the floor is open for Mr. Raja. Thank you, sir.
Thank you for that warm introduction, and I'm going to dive right into the presentation. Hi, this is Raja. My last name is Mani. People call me Raja Mani or Raja M, whatever you want to call. I work as a vice president in a company called TransPerfect, where we're really using all these container technologies in building cloud scale applications. So I'm going to start with the agenda for today's presentation. If you feel that I'm going either too fast or too slow, somebody let the host know, and Ravi Maran, please let me know if I'm going either too fast or too slow. Okay.
Okay, Raja.
Sounds good. So what is today's agenda? So we're going to start with what is DevOps? What is so special about DevOps? And then why DevOps? Then we're going to talk about the continuous STAR, that is continuous integration and continuous delivery steps, which are key steps in DevOps, and where in the DevOps virtual machines play a role, and how containers are taking over the virtual machines, and what is the difference. These two are complementing technologies. They are not competing technologies. They complement each other. And we're going to see a nice comparison between virtual machines versus containers, and why, what are the pros and cons of containers, and where we can still use virtual machines, and where we can use containers. And then we're going to talk about the de facto standard for containers, which is called Docker. That's the company that has come out with the runtime for containers in 2013. We're going to talk in detail about that. And if time permits, I'll talk about a container orchestrator platform, and it's a software from Google. It's called Kubernetes. So that's the agenda for today's presentation or talk. I hope that I can manage to cover all these things in 45 minutes. If not, Ravi Maran will. I promise you that I'll come up for another session and then do whatever is left over from this. Okay.
Okay.
Without further ado, I'm going to dive into DevOps. What is DevOps? Why is it so important? If you look at the way the software was built in the past, there used to be a methodology called waterfall methodology, which was a big disaster. There used to be a big upfront analysis cycle, then there's a design, then there's a development, testing, final deployment. By the time you go to production, your customers would have forgotten what was their first requirement. It was too late, too slow, big disaster. It failed big time in 80s. So then came Agile. There are many Agile frameworks like Scrum, Kanban, and so on. They are all very good, but then the DevOps is ruling the software industry now. It means it's a union of people, process, and products to enable continuous delivery of value to our end users. The sooner we deliver the software, the sooner we deploy, the sooner we get the feedback, the better for us. Because nobody wants to spend 6 months, and millions and millions of dollars or rupees to build a software without getting any feedback from the customer. So that's the beauty of DevOps. DevOps is the future. DevOps is the current and the future. Pretty much every software company uses DevOps these days. And if you look at that, the diagram starts with the plan. You plan, you build, and then you do a continuous integration, which we're going to see in the next slide about what is continuous integration, why is it important, and then you deploy. The product goes to the environment. It could be a testing environment or a production environment or an early beta cycle or whatnot, but the product is visible, the customers can see that, and your stakeholders, anybody can go play with the software, and then they can operate on that. They could start doing real stuff. They could log in, they could really work in the software, and then they could give feedback, continuous feedback, and then again that feedback goes into the plan cycle, and then it goes to the build cycle. So even though it looks like it's like a waterfall model, they all happen at once. They all happen in an iteration. That's the beauty of DevOps. What are those two steps that are very important? What is continuous integration? I'm sure most of you know what's a source control, where people, when we have a requirement and then we write some code, we have to check in the code into the source control system. But how do we know with the code that we checked in is a valid code, whether it is compiling, whether it is breaking any other, there could be so many members in my team, they are also checking in simultaneously. There could be more than one person working in the same function or in the same method of a class, and then there could be some conflicts. That's called merge conflicts. How could we know? The sooner we know the merge conflict, the better. Because what good is the software, what good is the code that you write that cannot be compiled and that cannot be run? So that's the beauty of continuous integration. There's a frequent merging and testing of code where it reduces time. We don't have to fight the merge issues, and it gives a rapid feedback on development teams. Oh, okay, Raja has checked in something, Ravi Maran has checked in something. Oh, did both of them succeed? Are they able to merge the changes that they made? Okay, good. That means the code is compiling. That doesn't mean it's going to run, but that's the next step. That's continuous delivery. What is continuous delivery? Okay, now we got some piece of functionality built by 2 or more developers, and they have no merge conflicts. The software is compiling. The product is ready. It could be a web application or a desktop application or anything. It could be Windows, Linux. Who cares, right? If it's a web application, it's got to be deployed to a web server. If it's a desktop application, it's got to be running on either a Mac or on Windows. The continuous delivery, what it means is, okay, now that I've written some code, it's been tested, it's ready to go. It's going to be ready to be deployed. So you immediately deploy it to your environment. It could be a production environment or it could be a testing environment. It doesn't matter. The organization, the people who are waiting for that software will get to see that. If it's a web application, they can go to the URL. That could be like, www.mmcollege.com or something like that. They could go there, they could see the software, and they could. It happens continuously. That's why it's called continuous delivery. And then there are build systems where you can check in and the build system automatically starts. It checks out the code, it compiles the code, it builds the code, and then it pushes to the web server, and then it sends an email to the whole team members, and they all know that, okay, whatever I built is now deployed, and testers can start testing, and whoever is waiting, the customers can start playing with it. That's these two continuous steps. What are virtual machines? Why are they so important? Virtual machines are like a software version of a physical computer. In those days, we used to buy expensive hardware. For example, you want to have a database server installed like Oracle or SQL Server, and then you want to run a web server like PHP Server or Nginx or IIS. People usually buy one powerful computer. They deploy the database server, they deploy the web server. They also put all the other application libraries, third-party libraries, everything onto a single physical machine as much as possible until it runs out of resources. That was okay back then, but that's not modern. That's not how modern applications are built. So people needed to exploit the power of the computer. A computer has CPU, RAM, and hard disk. You want to utilize network resources. You want to maximize. You want to put as many computers. You want to treat that one single computer as many as virtual computers you want. That virtual computer is called as virtual machine. It's a software technology, and every virtual machine has to have its own operating system. It could be a virtual VM running a Linux, or it could be a virtual. I would use the abbreviation VM for virtual machine. It could be a VM, Windows VM. It could be a Linux VM. It could be a Mac VM, whatnot. On a single physical hardware, you could run multiple virtual machines. Virtual machines, they need a complete operating system, including its own kernel, its application, the necessary binaries and libraries. So, which means it could take up several gigabytes of space, and it could suck up the RAM, it could suck up the CPU. So, if you look at the diagram, here's the hardware at the bottom. Can you see my cursor, or if you want, I can use a marker. Okay, at the bottom you see the hardware, and then there's this host operating system. For example, if you're running on a Windows Server operating system, you will have the host operating system, its kernel. And then on top of that, you run a software called hypervisor. There are so many virtualization technologies out there. VMware is a prominent company. Microsoft has its own technology called Microsoft Hyper-V. So whatever be the technology, you'll be able to create multiple virtual machines. If you look at this virtual machine block, a virtual machine needs an operating system, a full-blown, complete operating system with its own kernel, and then you deploy the application, you deploy the services, and as you can see, it's a heavyweight system. Even though you could run, on a powerful hardware with eight core processors, you might be able to run like 20 or 30 VMs, but it's still every VM needs an operating system with a kernel, which is super expensive. That's where the containers are going to save you resources, and it's going to help you run more and more applications. So what are containers? Containers are the natural and the next evolution in virtualization technology. A container, think of a container as a standardized unit of software. That definition is provided by Docker, who kind of is the leader in container technology. They are the ones who first ever built the container technology. So it's just a unit of software. And container, as you can see, is an isolated, lightweight silo. It contains, it doesn't need a full-blown operating system. It can run on top of the host operating system, so you don't need a kernel. You only need the minimal operating system concepts, which I'll explain in detail shortly. And then container contain only the application, whatever be the application, whether you're building a web application or a desktop application, the container will contain the application, some lightweight operating system APIs, not the full-blown kernel API, the user mode APIs, and then some services, and it will start sharing the underlying operating system. So it won't be in gigabytes. A container will be in megabytes. So you can imagine on the same physical hardware where you can only run 20 virtual machines, you have a possibility to run 50 or 100 containers depending on the size of your application. Modern applications, they are built using containers. They use the buzzword called microservices. A microservices is just a fancy term. It's nothing but an architectural pattern where you expose, let's say, for example, in the past, when we built an application, it was a monolithic application. You put your application logic, you put the web UI, you put everything in one, whether it's a client server architecture or a multi-tiered architecture, it is still monolithic architecture because there you have different layers. You'll have a database layer, people call it data access layer, then you have the application logic layer, then on top of that you have the web application, web UI or the desktop UI layer. But then still that application layer is a big monolithic layer. It cannot scale out. So that's where the microservices come into the picture. For example, when you are building a web application, you want to log into the web application. Then after you log in, people should know what permissions, what is the role. Are you an administrator? Are you a normal user? You're a reader user, editor user. Depending on the role, you will have access to certain parts of the application. That's called authorization. So why put application authorization? Let's say, for example, you're building an online shopping application. So your shopping card application, your credit card your credit card application that talks to the credit card providers to approve the purchase. And then there could be some email application, that you have to send an email to the customer as soon as the order is placed. If you put all of this application logic into one single monolithic layer, you will not be able to scale it. So you divide this logic by microservices, and every microservices qualifies to be deployed in a container. So if you, for example, on a busy day, you want to have 10 web servers, fine. Just the web UI alone, that container, you spin 10 of them. Okay, now you need there's the heavy purchase. Let's say, for example, it's a Christmas evening or a New Year evening. People are buying on your website left, right, and center, and then which means that your backend and your credit card module needs to be scaled down. So based on the need and the usage of the application, the traffic of the application, imagine if the application itself is smart about what layer to scale. Should I scale the database? Should I scale the UI? Should I scale the web services which are exposed using web APIs? That's what microservices is all about, exposing a functionality of a smaller subset functionality using a web API. That's why it's called microservices, and microservices are good candidates for containers. So if you look at the picture, in what way is it different from the virtual machines? The hardware is still the same. The kernel, the OS is still the same. But if you look at the container, you don't see the operating system at all. You only see your app and services, and your app has some minimal operating system APIs are there, but not the full blown. They all share both this in this diagram. Both these containers are sharing the same kernel, whether it is a Windows kernel or Linux kernel. These containers will share that kernel. So which means that you could scale this container. You could throw, the system can decide how many containers I want to spin, what type of containers I want to spin. Should I spin a UI container? Should I spin a database container? Should I spin a microservices container? Depending on the need of the application, it can scale out. It can also scale in. For example, after Christmas Eve is done, your site is going to pretty much be, nobody's going to even visit because everybody's tired. So the traffic goes down. Maybe it will go 1,000th of the traffic will go down. Why unnecessarily waste your memory and RAM? Why leave the containers running? The containers will be shut down automatically because there is no need for your application can happily run with 5 containers. It doesn't need 1,000 containers like yesterday because it was Christmas Eve and there were so many people using the application. So that is the beauty of containers. Any questions about containers? Because I'm going to go into Docker now. If there are no questions, if
No
there's
question, no
silence,
question.
I would assume that I can proceed. Okay. If anybody has any question, Ravi Maran, you can interrupt and you can pass on the question. I'll be happy to answer them.
Participant,
Okay.
if
Now
you
we are
have
going to see. Go ahead.
participant, if you have any queries, now this is the time to ask about the container. Still, if you have any query on this topic, that is container, now this is the time to ask, please.
Sure. If not, I'm going to go ahead and please feel free to stop me if you have any questions. We're going to have some categories, and then what does a virtual machine do and what does a container do? What is isolation? As you can see, a virtual machine is a software machine, is a software computer, which means it has its own operating system, own kernel, own process, own security boundary. It's completely isolated, right? And then it provides a complete isolation because of from the host operating. Your host operating system and your VM or the virtual machine, it has its own operating system. If your virtual machine crashes, it's not going to affect your physical machine. You can spin another virtual machine. That's the beauty. It's completely isolated. Container is also providing a lightweight isolation from the host and other containers, but as you know, it still depends on the host kernel. Okay, so it can provide some level of security, but not the full-blown security because it's not a complete end-to-end. It doesn't have its own operating system, but it is still secure.
Guest of sir.
Yeah, go ahead.
Hello?
Yeah, I can hear you. Go ahead. Hello.
No. There is an interruption. No
Okay, sure. I'm going to go ahead. So the operating system, but on a virtual machine, you run a complete operating system. You have your kernel. It requires more resources because the kernel will take up CPU, memory, and storage. Whereas in containers, it uses only the user mode portion of the operating system. It doesn't suck up the kernel because the kernel, it's going to use the kernel, share the kernel. So it can be very easy to build containers that can run only a small subset of the functionality of your big application. So it will consume only very few resources, which means you can run more and more containers on the same hardware. Guest compatibility. What is the guest compatibility? Say, for example, if your operating system is running on Windows, that means your containers will run Windows. If the operating system is running on Linux, your containers can run Linux containers. So you can have sorry about that. If you have the host operating system as one operating system, then the container predominantly will be on the same operating system because it needs to share the host's kernel. I'm sure it's obvious. So it runs on the same operating system version as the host. What is the deployment model? Well, if you want to deploy a virtual machine, you have two options. You can use a VMware or Hyper-V. They have nice graphical user interface where you can say create VM and you can create clone a VM. There are many operations that you can do. Or if you know the scripting, whether it is a bash script or PowerShell, if you are using Windows, you could programmatically create virtual machines and deploy them. That's the deployment model. Either you can use the GUI or you can use scripts. When it comes to um, containers, the containers can be easily deployed via command line. You can run a command line tool called Docker, and then you can start deploying containers one by one. Or if you can use an orchestration tool that can run multiple containers at once using a YAML file, and that one of the examples of an orchestrator is Kubernetes. So that's the deployment model when it comes to deploying containers. You could go one by one, or you could do massive deployments using Kubernetes. Operating system updates and updates. Say, for example, you run a Windows operating system, your virtual machine. There's a service pack 1, or there is some hotfix. How are you going to update it? You have to go to the VM, you have to log into the VM, you have to download the patch and then update it. Sometimes you may have to reboot the VM. It might take some time. It's very time consuming. Let's say, for example, you have 100 virtual machines running Windows Server, and then suddenly there's an update that came in. You have to physically go and deploy 100 updates. Somebody raised the hand. Cinderella Sebastian, what's the question?
Cinderella?
Can you unmute and talk?
No, sir.
Oh, maybe by mistake you pressed
No,
the...
no.
Okay, that's fine. Then let me continue. Okay.
Yeah.
Okay. So when it comes to updating a container, it's simple step. Every container has a description file called Docker file. You just go there and change the description to point to the latest version or the latest service pack image, and then you rebuild the container image with the base image. There's a base image. You create the first image, then you create a service pack 1 image, and then you rebuild the new image, and you push that new image into the container registry, and then an orchestrator like Kubernetes can pick up that most recent image and then deploy it, and you're done. Since you can have multiple containers, there is no downtime, because you can start updating container 1 and then push it, and then shut down container 2, and that can start using the new image. So you could quickly do the updates. That's the power of containers. Load balancing. I'm sure you all know load balancing. On a busy web application, you cannot have one web server. We'll have like hundreds of web servers. So when a request comes in, the load balancer figures out based on some algorithm. It could be a round robin algorithm, or there are many load balancing algorithms. Based on that, it will send the traffic to whichever web server is available, or whichever web server is free. So you don't have to worry about where the request goes. So you have to design the application in a stateless way, so that the request can go to multiple web servers. From the same computer, from the same client, it can go to multiple web servers. So the virtual machine load balancing moves the running VMs to other servers in a failover cluster. In a failover cluster means, like, if one VM is down, the load balancer picks up that failure because it has a heartbeat service. It pings every now and then to make sure that the web server is up and running. If it's down, it's going to just send the traffic to another one. In case of containers, the containers themselves, they don't move anywhere, because you can spin many containers. You don't move a container from one host to another host, because that's not needed. Because the orchestrator will automatically figure out if there's a failure, it'll start another container. It knows how to manage the nodes in a cluster. So that's how the load balancing happens. The orchestrator, like Kubernetes, manages the load balancing between containers. Fault tolerance. So when the VMs fail, the virtual machine servers can also be built as a cluster. So if one VM in one cluster fails, it'll start on another cluster. That's possible in virtual machine. In container, it's even more easier. If one cluster fails, any container running it can be rapidly recreated on another cluster node. That's because the orchestrator is watching. Oh, it's down. Okay, I'm going to spin a few more containers at the same time in another cluster node. So that's how the fault tolerance is maintained. Networking, you guys know it's a virtual network in virtual machine. Here it's an isolated view of a virtual network. There's a small private network in the container world. So you can share the firewall. There are many cool things that you could do in the container networking. Docker. Why Docker? What is Docker? So Docker is a de facto standard to build and share containerized apps from desktop to the cloud. You name any application, Docker, there's the Docker image available. Docker is the first company to build this container technology. They pioneered the container technology. This is this funny saying, when you ask developers in a software company, they'll say, oh, that feature works on my machine. It works on your machine may be true, but that is not enough because it has to work on a production computer. Most of the times it'll work great on your local computer, but once you check in the code, it's built and then deployed on a production server, it'll fail because you might not have the latest code from the other developer, or there could be some configuration problems that your local computer didn't have, but the production environment had. The environments, when you change from your development environment, local development environment, to another isolated environment, it could be a testing environment or a staging environment or a production, suddenly things will break. And so whatever you said, you confidently said, oh, it worked on my machine, doesn't matter. And Docker solved that problem, because if it worked on your machine, that same container image can work on anywhere. It can be it can work in your data center, it can work in a cloud platform like AWS or Azure or Google Cloud, because it's the same container. It goes, the application and its application dependencies, the binaries, the libraries, they all go as a big bundle. That bundle is what we call as a container image, as we call, and then the image, when it is run, it's called container. An image is like a blueprint, and a container is an instance of a container image. That's how it works. So that's the beauty of Docker. Docker container technology was launched in 2013 as an open source Docker engine. We're going to see what is Docker engine, what are the components of a Docker engine in the next slide. Docker leveraged already existing computing concepts. There were container concepts in the Linux world. They use some primitives called C groups and namespaces, and Docker smartly built on top of them to provide the application isolation. They used different namespaces and they used a C groups feature to limit the resources. C groups allowed the Linux to control what amount of CPU can this application use, what amount of memory can it use. That's why a container can easily scale up or scale down, and you can scale out and scale in containers. So because it's built on top of these cool technologies from Linux. What's the Docker engine? It's the industry-leading container runtime. It provides a standard packaging format for diverse applications. When I say diverse applications, you could run your desktop application, your mobile application, your web application, you can run anything in Docker engine. That's just a beautiful diagram taken from docker.com. Docker engine, it has a Docker API, it has a Docker CLI. CLI is command line interface. There will be a cheat sheet that I'll show you, which will show you some of the important Docker commands. And then the Docker engine has distribution, orchestration, volumes is the disk. How does the disk volumes are shared across containers? There's a container D process, and then there's a Docker build. How do I build a Docker image? How do I build a Docker image from a Docker file? And then there's networking, as we talked about. And there are lots of other plugins as well. So this whole thing is called a Docker engine. Docker creates simple tooling and a universal packaging approach. You can have for example, a web application will, if it's a Microsoft ASP.NET Core application, it'll have some assemblies and it'll have some third-party assemblies. Your front-end applications will have some CSS files, some JavaScript files, some HTML files, or your Angular or a React application will have its own TypeScript files, which will be processed into a JavaScript file, and then JavaScript will be bundled. All these things constitute an application. So you can choose what goes into your container, and you can call, okay, this is going to be just the user interface container. Oh, that is going to have just the authentication and authorization web APIs. Oh, that container is going to have my application shopping cart logic. So you figure out what you want to push, what piece of application, what microservice you want to put inside a container, and then you deploy it using Docker. Docker engine, it enables the containerized applications to run anywhere consistently. You don't need the dependency hell. For example, let's say you are using PHP version 5, or let's say, for example, you have an application that's running on Python 2. You build another application that requires 2.5 and another one requires Python 3. You could have multiple containers, the same application with multiple environments of whatever the whole application and its dependencies are packaged. So there is no conflict because you are not touching anything on the host computer. Your application itself is self-contained, and you can spin thousands of them in no time using Orchestrator. So there will never be a DLL hell or something that is broken. Oh, it was expecting version 2.5. Oh, on my computer I only had 3.0. I didn't have the old version. There is nothing of that sort will happen because you are the one who is building the image. That image contains everything. What version of your web server you want, what version of your database server you're talking to, what drivers you want, whatever the exact dependencies of your applications are bundled in the container. So there is no way it's going to break. That's why when you say it works on your machine, it'll work on your data center, it'll work in your test lab, it'll work in the cloud like Azure or Amazon, because it's the same container image that gets pulled and it's run by the same runtime engine called Docker engine, whether it is running on Google Cloud or Amazon Cloud or Microsoft Azure Cloud or on your local data center or on your local desktop or laptop. It doesn't matter. It runs everywhere consistently because it's the Docker runtime and your container is self-contained. That's the beauty of containers and Docker engine. What are container images? What is a container repository? What is a container registry? We're going to see all these things to understand the pieces of Docker. If you look at the Docker container image, we already talked about the connection between an image and the actual container. Think of your source code, your classes. If you've done Java or C++, your class is the blueprint. Your object is an instance of the class. That's the same relationship. Your container image is the blueprint. Container is the actual running instance of that container image. It's as simple as that. So like we talked in the previous slides, it provides a lightweight, standalone, executable package of software. It's a functionality, a small functionality of a big application that is containerized, stored in a small container, and it has everything that's needed. Like I said, it has the code, it has a runtime, it has the tools that it needs, it has the libraries, settings, everything is in that container. So your application or that piece of application will never break. It'll run anywhere. Container images become containers at runtime. It's a no-brainer. It's a blueprint. Once you run it, it becomes a container. So the image becomes a container. A Docker repository is a collection of the related images. For example, you create a Windows image or a Linux image, and then later you want to just deploy a web server on that image. So you can have one image and you can have multiple versions of the same image, and you call that version as a tag. So the tag is an alphanumeric identifier attached to the images within a repository. You could call your repository as, let's say my name is Raja. I created my own web application, my Raja _ shopping cart _ v1. That's the name of a container. Let's say I made some improvements. I just added one small additional method to my microservice. I wanted to call it v2 version 2. I just add an additional tag. So even though it's the same image with one additional method, so it's that's the repository. It's a collection of similar images, but they're versioned, and you can identify them using a tag. Then what is a registry? A registry is a service. It stores all of your Docker images. It can contain a repository of Docker images. You can store any number of images into a registry. It need not necessarily be hosted by the Docker company. Docker has their own registry called Docker Hub, but you are welcome to. There are so many other popular Docker. There are so many other popular registries like Amazon registry. There's an Azure container registry. There is a Google container registry. You are welcome to store your images anywhere. You are not stuck with Docker Hub alone. Even Docker Hub has two options. There's a public registry, there's a private registry. Let's say, for example, you do not want people to just do a Docker pull of your company's web application. You don't want to be pushing your company's business intelligence to a public registry. So you could buy a subscription, and you could have your own private registry that only you will have access to because you need to provide the credentials to pull an image from that registry. So all these third-party registries that I told you, the Amazon registry, the Azure container registry, the Google container registry, they all provide both public and private registry. So it's up to you to use whether if it's an open source project or if it's an academic project, you don't want to spend the money, you're welcome to push it to a public registry. So anybody can search for your image and they can pull the image, they can run that image. They can run when the image is run, it's called a container. The container is running the application. So here's an example of a containerized application. There is an application app A, app B, app C. Every one of them is a container. As you can see, they are isolated. They are run using the Docker runtime, which is an application running on top of the host operating system where the kernel is sitting, and then there's the hardware infrastructure. So this is how a containerized application is layered and deployed. Docker, like I told you, Docker started on Linux. It built on some cool Linux concepts like namespaces and C groups and many more. So Microsoft worked very closely with Docker because they like the container technology, and they upgraded their Windows operating system to provide supports for namespaces and all the features that Linux had. Windows Server started building that. So that's how Docker was available on Windows. Docker and Microsoft had a joint partnership relationship to deliver a consistent Docker experience. Just like how Docker ran on Linux, Docker runs consistently on Windows as well. All the Windows Server 2016 versions and above, most recent version is Windows 2019. All of them, they all ship with a Docker Engine Enterprise version with the operating system itself. A developer can leverage Docker in the first earlier versions of Docker. When you want to run Docker on Windows, you cannot run because Windows didn't have the container features at all. So what Microsoft did was Microsoft has their own virtualization technology called Hyper-V. So they spin a Linux virtual machine, and then the Docker ran inside the virtual machine. So like I told you, virtual machine and containers are not competitive technologies. They are complementing technology. They can be built on top of each other. So in the earlier versions of Windows, the only way to run Docker was to run Docker inside a Linux virtual machine running on the host Windows operating system. So that was back then. But once Windows Server 2016 released, and even the Windows 10, now there's a version of Docker called Docker Desktop that runs on Windows machine, but it's still built on top of the Linux machine. And the most recent version of Docker Desktop does allow you to run native Windows containers. The only drawback of that is when you run the Docker Desktop software, you have to run it. You can only run in one mode. You can either run it on a Linux mode or you can run it on a Windows mode. When you change the mode, you have to restart the Docker runtime. That's a no-brainer. The Docker Windows containers work the same way as it does on Linux. Same Docker command line interface command. All the commands work. It's the same API. It's the same image format. Same distribution services. Same Docker hub can be used to pull a Windows image or a Linux image because Docker's promise is that it'll be consistent, it'll run everywhere, so it cannot be different. So a Docker Windows container or a Docker Linux container, they both work. Here's the Docker cheat sheet. There are some commands that I could show you some sample Docker commands, and then I already have the Docker desktop installed on my computer. So if you want to see that, I could show you a few cool commands. So let me open up my command line shell, and then I'll bring the shell to the other screen, and I'll show you some commands that you might be interested to run. So I have a command line shell called commander. It's if you are on Windows, you are used to using command.exe or PowerShell. The commander can abstract both PowerShell and command and the regular command.cmd.exe. So here's an example. So the first command that I wanted to show you is, can you see my commander? Let me bring that over here. Just give me a second. I'm going to drag it to the other screen. Just give me a second.
Not shared, Raja.
No, yeah, I haven't started it. So I'm launching a new command line tool, and you should be able to see that now. Do you see a commander PowerShell.exe?
Yes, yes.
Okay, so I've already installed Docker desktop on this computer. So I'm going to run the first command, which is a very simple command. You want to just run Docker. As I told you, the Docker CLA, all commands start with the word Docker version. It'll tell you the version of the Docker that you're running. And then Docker, when you install Docker for desktop, it comes with a few sample image files already. So for example, you could do a Docker run hello world. There's a hello world image. So as you can see, it was trying to find that. Since it was not there, it just pulled it. The funny thing is, you'll run, it says, yes, you can see, do you see the word hello from Docker that I highlighted? Can you see that?
Yes,
Hello
yes.
from Docker. So what happened now is Docker, it was looking on the local computer, hey, do I have a container named hello world, and colon, anything after colon is the tag that I talked about. If there's a tag called latest, you don't have to remember the big alphanumeric identifier. If you just say latest, it'll go to the Docker registry and find out, hey, I am looking for a container named hello world. Whatever is the latest version of that image, please give me that, download it. So it's pulling from the library, and then it pulled, you can see the pull complete. That means now that image is downloaded onto my local laptop. Then it immediately ran that command, ran that image. It's a Linux image, and then it was running a command called echo hello from Docker. So this hello from Docker is not run on my host laptop. It was run inside a Linux container, and then it killed the container, and it came out. So if you want to see what all images I have, I can type a Docker image ls. Ls is the list command. As you can see, I've been using Docker and Kubernetes on my computer because I'm building my application on my computers. So you can see that I have so many images. So there's anything that starts with this Docker space means it's coming from Docker hub. Anything that starts with K8s comes from the Kubernetes Google Container Repository. As you can know, mcr.microsoft.com is from Microsoft. So, and you can see the tag. Like I told you, there's a tag called latest. There's some nice tags called version 1.1. The tag is a friendly name. You can give anything you want. And then there's an image ID. When was it created? And what is the size of the image? Like I told you, if you were to get this Linux image as a virtual machine, it won't be in megabytes. It'll be at least a few hundred megabytes or at least a gigabyte, depending on which distribution of Linux you're using, whether it is a Red Hat or SUSE or whatnot. So that's why the containers are very lightweight, because they don't contain any operating system footprint. It only has the application and operating system, minimal operating system files, user mode files. And there are so many other containers that I have. I have Elasticsearch container. I have all other containers that if you want to see what all the Docker processes that are running right now, I can do a Docker ps -- all. It's telling me, hey, you ran a container, and then inside you ran the image called hello world, and then you ran a command /hello, and then it ran and it immediately closed because it exited in 2 minutes. That because I could make a container do something and hang in there, wait forever, or I could have a container that does something and then immediately returns and closes it. So that now you have an option to run any number of containers you want. For example, let's say I want to run the getting started container, right? Here I was pulling the hello world container, right? Like that, there is something called getting started containers, which is a beauty. It's a Docker tutorial which is running inside a web application in a web server. That itself is available as a container app. So we are, for the kicks, we are going to pull that image onto my computer and we are going to run it. Okay, so I'm going to do a clear on my screen so you can see the command. I'm going to copy and paste the command. I'll explain this command a little bit so you can understand. Docker is the command line tool, run is the command, and then don't worry about the -dp and all the stuff. You're running, this is the port that you want to expose your web application inside the container onto your host computer. On my host computer, I may be running many web applications. They may be sucking up port 80, 81, and so on. So if I do an 8080, if on my local computer, local laptop, if I am already running a web application on 8080, there's going to be a port conflict. So what I'm going to do is I don't want to waste time troubleshooting that. So instead I'm going to change the port from 8080 to, I'm going to just say, go to port 8085. So what this command means is run this container named docker/getting started. If that container is available on your local computer, it'll immediately run. If it is not available, it will note to pull it from the Docker registry, bring it to your local computer. It has a Docker file that tells what should be done once the image is brought to the computer. When the image runs and becomes a container, there is a Docker file that tells what it should do. And then in this case, it's starting a simple web application. And then that inside the container that is running on port 80, but I cannot access port 80 because on my host computer, port 80 is already used. So I am mapping that container's port 80 to my host computer's 8085, port 8085. Okay, so I'm going to hit enter. So it's going to run this command. Since the image is already there, it immediately ran. How do I know it's working? Fire up the browser and go to the port 8085, and you'll see that it is running the container. And before you do that, how can you know that that container is running? Remember the command docker ps all that we can run. See that docker getting started, that image is running. Okay, so now I am going to, these names are funny names. These are automatically given by Docker. It'll change every time you run a Docker. It's a funny name. It'll give some random names. Okay, so I'm going to open up my Google Chrome, and then I'm going to go to port 8085. I'm going to launch the browser. I'm going to bring it to the other screen. And you should be able to see it now. I'm going to go to localhost 8085. And if everything works, look at that. This doc getting started, this is a web application. This is a web help. It's a static web application that is available to you as a container in the registry. So I don't even have to imagine before the containers. If you only had virtual machines, what will you do? You will have to go download the source code. Well, let us say, for example, this is a PHP application, or even if it's a JavaScript application, you need to build the application. You need to deploy the style sheets, the CSS files, the image files, the entire web application. You need to deploy it onto the virtual machine. If it's a PHP application, you need to install PHP. Then you have to install this application, and then you will go into then you will hit that URL. Heavyweight. You wasted an operating system. You are wasting a lot of resources. Now all I did was just pull an image and it ran. I'm running it. It's available to me. It's tunneled to the port 8085 from inside that container. So that is the power of Docker containers. Okay. I think we're cutting too close to the time of the presentation. If you guys have the energy and patience, I could jump into Kubernetes. But if not, I think we've just hit 45 minutes from the time we started, I think. What do you think, Ravi Maran? It's almost 50 minutes since we started.
Yeah.
Should I continue or?
Yeah, how long it will take? Another 5 to 10 minutes?
No, Kubernetes will take a lot of time because Kubernetes is an orchestrator. It has a lot of I can show you the slides. It has a lot of components. And it's like 5 slides. This is the architectural diagram of this is how a Kubernetes cluster will look like.
Just to give an abstract of this, and we will proceed.
Sure. I may not be able to run the command line like how I showed a glimpse of Docker.
Just to give an idea about the Kubernetes, and
okay.
then we'll complete.
Sounds good then. Let's go ahead with the Kubernetes. Okay, I'm going to drink some water. Okay. Kubernetes is a Greek word. Kubernetes means a captain of a ship. So as you can see, Kubernetes is pronounced as Kubernetes, which is a Greek word for helmsman of a ship or boat, also known as a pilot of a ship. It's referred to, you can call it K8s or K8s, K8s or K8s. Kubernetes originated from Google. It's an open source orchestration software for deploying, managing, and scaling containers. Docker doesn't provide all this. Docker provides only container runtime. If you want to deploy it, if you want to scale it, if you want to automate the management, if you want to automate the deploying, monitoring, everything, there are additional Docker plugins, but you will want a full-blown orchestration tool. And Kubernetes, just as how Docker is the industry leader and de facto standard for containers, Kubernetes is the de facto standard for container orchestration. Kubernetes is used to build, deliver, and scale containerized apps faster. There is no R, I'm sorry, I missed R. It allows us to make the workloads portable because you have a container, the container itself is portable, and Kubernetes at will moves these containers from one node to another node. And we can easily move them from local machines to production because Docker is guaranteed to work irrespective of where it runs. And Kubernetes is just an orchestrator built on top of Docker, which means it automatically borrows all those powerful features of Docker. Whether you're running it on a local computer or you're running on a developer lab or a test lab or the cloud, Kubernetes will be able to move this. They use the word pod. Pod is nothing but a nice wrapper on top of container. We are going to talk about pods in the next slide. So for now, we'll use the word container. Kubernetes can move the containers at will from one location to another location, and still the application will run without breaking because you built the application as a containerized application. It can handle multiple cloud environments. It can talk to Amazon Cloud or Google Cloud or Azure, Microsoft Azure Cloud. It will maintain consistency across environments. It allows us to scale the containers. You must have heard the word elastic scaling. Like I said, on a busy Christmas evening, an online shopping site will be super busy. So it needs to know when to scale elastically. So go from 10 web server nodes to 1,000 web server nodes, or from 10 database nodes, 100 database nodes, or all microservices. You go from 100 to 1,000. On that busy day, it'll elastic scale. And then once the traffic is down, it'll go back. It'll reduce the resources. So that kind of an orchestration, that kind of an elasticity is possible through an orchestration tool like Kubernetes. Because this Kubernetes can understand a cluster of servers, and it figures out based on your requirements of elasticity, it knows where to deploy what. There's a large open source of community developers and companies. They actively build extensions to Kubernetes as well. They add security monitoring, management, all those cool things are built on top of Kubernetes by community developers. What are the Kubernetes components? This is a single cluster diagram. It has two, as you can see, it has two major parts. One side of it is called Kubernetes control plane. The other side is called Kubernetes nodes. So inside of the control plane, you see like 5 components. Here you see things like kubelet and kubelet proxy. So that's what this slide is all about. When you deploy Kubernetes, by default, you get a cluster. That's what you're seeing on this diagram. A Kubernetes cluster, it consists of a set of worker machines. Worker machines is where your real application stuff happens. Your application is running on the worker machines. They are called as nodes. They run the containerized applications, and every cluster has at least one worker node. But in this case, you can see that there's 3 cluster nodes. There are 3 Kubernetes nodes in a single cluster. Like this, you can have multiple clusters. This is just one cluster. You can have multiple clusters as well. What is a pod? I said a pod is just as how in containers, a container is the execution unit. In Kubernetes, a pod is the execution unit because a pod can contain one or more containers that are related. That's why a pod is an abstraction that is built on top of containers. It's the basic execution unit. It could be an application, which is the smallest and simplest unit that you can create. In Kubernetes, you'll only say, I created a pod, I deployed a pod. You don't say, I created a container or I deployed a container, because pod abstracts or wraps the containers. A pod represents a process running on your cluster. For example, in this is running a pod. This node is running another pod. This is a pod. A pod represents a unit of deployment. It could be a single instance of an application, which might contain a single container, or it could be multiple containers, microservices talking to each other. They are all tightly coupled, and they may share some resources. That's why the pod is a higher level concept. It can package a container. the control plane, the left-hand side, that is you can very easily understand. Like on the right side is where the real application gets deployed, but who is going to manage where to get deployed? That is the left side. That's the control plane. It has so many things, and we're going to see them one by one. Kube API server. This is the API server component of the to manage Kubernetes. You'll be talking to this API, Kubernetes API. That's the front end for the Kubernetes control plane. Then there's the etcd process, which is a key value store, because your cluster data, it has to track the cluster data. Where is my pods getting stored? Those are all maintained in a key value store, and that store is the etcd process. Kube scheduler, as the name implies, this is the one that watches for a pod, which pod gets assigned to what node, and what node should be selected. Where should I, okay, depending on the load, this node is busy. Okay, I'm going to deploy this pod on that node, which has resources to run this pod. So the scheduler figures out where to deploy what. And the Kube controller manager, that, as you can see, that runs some controller processes. And even though these are all separate processes, for convenience, they are all built, all these controllers are built as a single binary and deployed as a single process. There's a node controller responsible for noticing and responding when the node goes down. Because when the node goes down, all the pods in the node goes down, which means that you have to immediately create new pods on a new node so that your application doesn't go down. Replication controller, they are maintained, they replicate. Let's say, for example, in the Kubernetes YAML file, I say that for my application, I always need 5 pods. So who's going to make sure that 5 pods are always up and running? That's the job of the replication. Endpoints controller, there are some joint services and pods. There's a service account and token controller, which contains the API access tokens. This is all, management stuff. The cloud controller manager is a powerful component. Like I told you, the Kubernetes doesn't care where it's running the pod. It can run on your local computer, on your local data center, or it can connect to different cloud providers like Amazon, Google, or Azure. So that's why the cloud controller manager knows what cloud specific logic it needs to understand. If I'm deploying on an Amazon cloud, what should be done? If I'm deploying on an Azure cloud, what should be done? So it knows what to do. And then if you're running Kubernetes, it doesn't matter. You can run it on your own premise. When you say own premise, on your college network, on your lab, or on your own computer, or on a cloud. This cloud control manager that knows how to talk to those cloud providers and deploy the pod. These controllers have the cloud provider dependencies: node controller, route controller, service. These are all depending on this cloud provider, because every cloud provider is different. The worker nodes is the other side where the actual application runs. That's the real component of your application workload. Node components. What are the components inside that right-hand side? The node components, they run on every single node. They maintain the running pod. They provide the Kubernetes runtime environment. And a kubelet is an agent. Every node has a kubelet. It makes sure that the containers are running in a pod. That is the one responsible to run the pod. A kube proxy is the network proxy that runs on each node, implementing the Kubernetes service concept. So the kube proxy is required to abstract the network. Container runtime is predominantly the Docker is the #1 container runtime, but Kubernetes support other container runtimes as well. As long as they all follow the container, the Kubernetes published something called CRI, Container Runtime Interface. Of course, Docker implements that interface and methods. So any container runtime that implements that CRI interface methods can be managed by Kubernetes. That concludes our session. If there is any questions, you are welcome to ask now. Thank you everyone for attending this container technology presentation, and thank you Ravi Maran for the opportunity to share with my
thank you, Rajat.
students and
Thanks for
faculty.
your amazing presentation on this container technology. So before we can take questions from the audience, M.A. Magaman Nizam to say a few words. Sir, please, sir. Hello?
Hello.
Sir?
Yes,
sir, please.
Good morning to dear students, faculty members, and today's speaker, Mr. Rajamani. It was really a wonderful session. We all experienced with respect to the container technology. I believe that my students and staff has been enlightened by your talk. Thank you very much for spending the time. I believe that as promised by Mr. Rajamani, frequently your talk will enlighten my students. And I thank on behalf of my students because the technology plays a very vital role nowadays. Because of the latest technology and the virtual learning, now the students are of the culture to inhabit or adapt whatever the latest and the future technology. And I once again thank the principal. I was told that Mr. Rajamani is the friend of my principal, and so I have the privilege to request Mr. Rajamani to often, whenever you are free. I know you are very busy in your company.
Yeah. I
anyhow,
wish I could meet you guys.
anyhow, you have
I'll-
enlightened our students by giving a wonderful presentation, of course. So I would request you to, whenever you have time, at least once in a fortnight, to give a small module of talk to give them way to develop such type of softwares. I thank you, my dear Mr. Rajamani. Thank you so much.
Thank you.
Thank you,
Thank you
sir.
so
Thank
much.
you.
Thank you.
So now we'll go to the question answer session. So now the floor is open for all the participants to ask questions. So if you want to ask questions, you please unmute your mic and ask your questions, or else you can type it in a chat box, please.
Yeah, either way is fine. I will check the chat window as well.
There is one question from Mr. Anand. How to give permission for using host OS port?
Could you please repeat the question?
How to give permission for using host OS port? Ports.
Host OS port. There is a command called netsh that will allow you to allocate permissions, and you can open up the firewall to allow ports using the net shell command.
Yeah. If running web servers and database in Docker, what about license cost?
You're lucky. Most of these containers come with the open source version of the databases. The containers that are available for you from Microsoft or from Docker, they already cover you the licensing. If it's a commercial software, you'll be paying some cost for the images. But most of these images these days, even SQL Server is now running on Linux, and you don't need to pay a license cost. Only when you're deploying it as a commercial application, you will have to pay. You have to get the license. You can deploy your own licenses inside the containers, and you can create your own images as well. In such situations, for example, in my company, I don't use the ready-made images, the public images. I build my own images with the licensed version of SQL Server, the licensed version of Windows operating system, and then I have my own private images inside my Azure registry. If you want to run a commercial software, you would want to do that way rather than picking a publicly available open source version. Does it help?
Yeah, thank you, Raja.
Yeah.
There is another question. Is there way to limit CPU usage to particular Docker?
Absolutely. At a Docker level, you don't do that, but as an orchestrator, like in Kubernetes, you can tell I do not want my my pod to go over certain resource limits.
Okay.
In Docker, you can do that, but what is the advantage of doing that? Like you'll only be able to control one container. You can say this container in this Docker file, we can say that this can only take up to this much RAM. But when you're scaling out, you would want to use an orchestrator where you would control, hey, all web server nodes should follow this many CPUs and this much of RAM. So let the orchestrator go at will, create that many containers using that resource limits. You don't want to do it at the Docker level.
Okay. Thank you. Any question from the participants, please?
Sir, good morning, sir.
Hi.
Good morning.
Good morning, sir. I'm Ilamati from CAC department, sir.
Go ahead.
Which container technology is best, sir?
What do you mean by which container technology is best? Docker is the number one. Docker is the de facto container technology, and Kubernetes is the de facto orchestration technologies that you would want to choose because of their popularity and the number of images that are available out there. Docker rules the container market now. Similarly, Kubernetes is from Google, which is another big company, as you know, and there are lots of open source contributors. So you would naturally want to choose Docker as your container platform and Kubernetes as your orchestration software.
Okay, sir. Okay, sir. Thank you, sir.
And if you want to deploy it on cloud, you have a choice. For example, in my company, I'm using Azure AKS. It's called Azure Kubernetes Service, where the Kubernetes, I don't want to run Kubernetes on my computer. I run the Kubernetes on the Azure platform. Azure is very good. So is Amazon. So is Google. Between these three, there's nothing. I like Azure just because I like it. I mean, if you like Amazon, you can deploy all your Kubernetes and containers and pods on Amazon Cloud. Amazon gives you some free, so is Azure. Azure gives you some free services up to certain usage. After that, you have to pay for the subscription.
Okay, sir. Thank you, sir.
There is another question from the chat box. Whether is
Go ahead.
OS is required to run containers? Without OS, is it possible?
There are serverless containers, but you would definitely, at the end of the day, you will need a host operating system, minimal host operating. Without that, how could your application needs at least something, right? Whether it is a web application, your even if web server, whether it is an Nginx server or IIS, it needs some host operating system.
Yes.
But the container itself doesn't contain any operating system elements. It only has the user mode elements. But even when you write an application, right, you will have paths. In Linux, you'll say $/user/Ravi Moran. Whereas in Windows, you'll say C:/users. So your application, whether you like it or not, will have some operating system specific elements there. Which means that even though your app will have some operating system dependency, but you don't need the full-blown operating system. You can pull a minimal Windows image, which is like 10 MB, and you can run your application, and that will use the underlying host operating systems, Windows operating system, for the kernel calls.
Okay, thank you, Raja. There is another question. What is the benefit of using Docker over hypervisor?
That's a great question, because you can deploy Docker on a physical machine, right? Like I told you, the hypervisors are powerful. So in ideal world, people always never deploy Docker on a physical computer. They have a physical computer, then there's hypervisor, whether it is Hyper-V or VMware, and then on top of that they deploy Docker, because that way you can have. See, I told you that on a Docker desktop for Windows you have a limitation, right? You have to only run either on Linux mode or on a Windows mode, right? Let us say you have a need to run. For example, my application is hybrid application. Some services run on Linux, some services run on Windows. So at that point in time, I need to have a Windows host computer to run the Docker on Windows mode, and a Linux computer to run Docker on Linux mode, because this Kubernetes installation can run Linux pods. That other Kubernetes installation can run Windows pods, but I'm stuck on the Docker desktop because I don't have that power. Whereas on a Windows server or on a Linux server, I could have a hypervisor installed, and I can have two virtual machines, one virtual machine running a Windows server, another virtual machine running a Linux server, and I could put a Kubernetes on that virtual machine, another Kubernetes on this virtual machine, and I can run all of my Linux pods on the on the Kubernetes installed on Linux, and all the Windows pods, Windows containers or Windows pods on the Windows virtual machine, Windows server virtual machine running on that. But the underlying host doesn't matter. The host could be a Windows server or could be Linux. As long as the hypervisor supports can support both Windows and Linux, I could run two virtual machines, and I can put two Kubernetes. I can run multiple pods. So that's why I told you virtualization, Hyper-V technology, and containers are complementary technologies. Does it help?
Thank you, Raja. Another question. What does the volume parameter do in a Docker run command?
It defines the volume. You know the mount points, right? In Linux, you have to have some shared storage. If you want your container to use a piece of hard disk or a piece of storage, that's what the volumes are mount points that your system can write to. It's a disk part of it, because an application needs access to disk as well, right? because when you run a container, it has its own virtual file system. It has its own file system. But if it wants to access a shared resource, let's say, for example, two containers need to talk, both needs to write to log their log, your application will have log files. If they need to write to the same log location, then it needs to be a shared volume mounted that is accessible from both these containers so that they can talk to the mount point.
Thank you. Thank you. Any other questions from the participants?
Sir, good morning, sir. I am Rajesh Ram.
Yeah.
Hi, Rajesh.
Sir, I have one question, sir. How about that migration and the cloning options in the Docker,
containers?
sir?
In containers or virtual machines? In containers?
Containers, sir.
In containers, you don't need to clone anything because your orchestrator can create. See, what's the big difference? In the first slide, I showed you the difference between VMs and containers. VMs are heavyweight, right? To boot a VM, your operating system has to be started, right? You know how long it takes to start a Windows operating system. You know how long it takes to start a Linux operating system. In containers, there is nothing to start, so there is no need to clone. You can start a container in a fraction of a second, and you can run any number of containers. So there is no need to clone because you are not cloning your container. You have a specification. It tells this container runs my web application. This is on this port. This is the application configuration parameters. You give all these configurations. That's why containers are called IAC, infrastructure as code. You define your infrastructure. I can write an YAML file that tells that my pod requires two CPUs, two virtual CPUs. It requires 10 MB RAM, and it requires this this much disk space, and you can scale up to 10 containers. If you give this specification file, the Kubernetes will figure out this guy needs 10 of these pods. It will figure out which node is free or which one of the nodes have enough resource. It might put two pods in one node. It might put 5 in another. It might put 3 in another. So there is no need for you to clone anything. You are only using the configuration. The infrastructure is defined in a configuration file. It reads the configuration file and creates containers and pods just like that. So that's the equivalent of cloning. In virtual machine, you don't have this concept. You have to create the virtual machine, clone it, boot the operating system, then only the application comes up, which is very expensive. Does it answer your question, Rajesh?
Yes, sir.
Is it
Thank
clear?
you, sir.
Yeah.
Raja,
Nandini, please you unmute your mic and you ask your question, please.
Raja,
Yeah.
yeah, I'm Shivkumar from BH Trichy.
Hey, Shiva, how are you?
Yeah, fine, G, fine. After a long time, I'm hearing your voice after 25 years.
Hope it's not old.
Yeah,
It
yeah.
sounds still.
I have one doubt about this. I mean, it's very useful information provided by you to all. At the same time, will it work in the multiple platform?
When you say multiple platform, what do you mean by that? Do you mean by the operating system or?
Different OS.
Yeah, of course. You can have the same app run in 10 different versions of Linux, SUSE Linux, Red Hat Linux. See, if you look at the container contains everything. Your version of whatever version of the operating system, the version of your web server, the version of your database, everything is self-contained. So you could spin a container using Windows Server 2012, 2016, 2019, or Linux Server or Mac OS. There are containers available for different flavors of operating system. As long as the operating system supports the container concepts like namespaces, whatever those concepts that I talked about, the container technology. As long as Docker runs on that operating system, you can create any number of containers on that OS, on that platform.
Okay, thank you, G. Thank you for
You're welcome.
Thank you
also
so much.
used information, and also thanks to Mr. Ravimaran for organizing this program. G. Thank you.
Thank you, Siva. Any other questions?
Good morning,
the
sir.
audience
Senthil
side?
from BHL. Hello.
Hello.
Yep.
Good morning, Senthil Kumar from BHL.
Hi, Senthil. How are you?
The session was really interesting and very nice. Enjoyed it. Basically, we are a Java development team at BHL.
Yep.
We are developing Java-based web applications for BHL Tiruchirappalli. So we use object bean technology. In-house developed object bean, and we used to develop applications, and basically we deploy it in a Tomcat server. Our development environment is Tomcat server.
Absolutely.
Then our testing environment is IBM Sphere. So while migrating this thing, we used to have this thing like some libraries would be missed out.
Exactly.
The development environment and the production is not same.
Yep.
So we used to have this problem issue. So I could understand this how this container technology.
You are going to love containers.
Yeah.
There are so many Tomcat versions containers available for you. There are so many IBM WebSphere containers available. You can pull whatever version you like, and you can put all your dependencies, and you just push your application to that. And once you create the container, push your image to your BHL private repository. Anybody can pull the repository, run it anywhere, it will work. You don't have to worry about what Tomcat version, because you already decided the version of Tomcat.
Sure, sir. Thank you for your wonderful session, sir.
Thank you, Sandeep.
Thank you.
Hi,
Raja. Hello.
Hi.
Hi, Raja. I am Chandrasekhar from Karaikal.
Hey, Chandra. How are you, man?
Fine, fine. What about you?
I'm doing great. Can you turn the video on so I can see you?
Hello.
Yeah, I can
Hello.
hear you. Go ahead.
Yes. This is the first time.
Chandra, just switch on your video.
Yeah, turn the video. There'll be a video camera at the bottom. If you click on that, I'll be able to see you.
Okay. Raja, even though this is the first time I'm hearing about that container technology.
Yep.
You have given very good input regarding the container technology, Docker, and Kubernetes.
Thank you. I took several weeks to learn this.
Yes, you have created interested on working on that topic, container technology. Thanks for the information, and I also thank our Dr. Ravimaran for organizing such a wonderful session webinar.
Thank you, Chandru.
Thank you, Raja. Thank you.
It's a pleasure. It's a pleasure to talk to Chandrasekhar. For people who don't know, Chandrasekhar is a class topper in our class. He's an amazing person. He excelled in both mathematics and computer science. You should give some presentation someday, Chandrasekhar.
Okay, definitely. Definitely, Raja.
And Ravimaran, he should arrange a session from Chandrasekhar and Shivakumar as well someday.
Yes.
Yep.
This is the first time I'm hearing. I am also connected with our BHL Shivakumar also. Almost 3 of our friends are connected, I think.
Is online in Zoom.
Okay, ma. Thank you, ma. Thank you. Bye.
Thank you.
Any other question from the audience?
Good morning, sir.
Hi.
Hi, myself Nandini from M.A.M. CE.
Hi, Nandini, go ahead.
How far Docker containers scale? You already said Kubernetes requirements for scaling purpose. Any other scaling or otherwise other than Kubernetes? Any other requirements are there for scaling?
Kubernetes, there are so many other orchestrators. I don't remember the name of them off the top of it. If you Google for Docker or container orchestrators, you'll find a few more orchestrators. There's a Docker Swarm. There's another orchestrator called Swarm, SWARM, Swarm. But you don't need anything besides Kubernetes. Kubernetes will do. Kubernetes runs in Amazon Cloud, in Azure. So just imagine a company like Google. They are using Kubernetes to scale their search servers. Then you can imagine the load that google.com gets, right? Their Google application, they're all running using Kubernetes. Then what more do you need? We will not even, our traffic will be a minuscule percentage of Google's traffic. If Google can run on Kubernetes, that's a testament for Kubernetes, right?
Okay, sir.
Thank you, Raja.
Thank you, sir.
So is Microsoft. Microsoft uses Kubernetes internally for their web applications as well.
And one more question, sir. Can we use a different Kubernetes for a different virtual machines? Why, sir? You already said we are using a different Kubernetes for a different virtual machines. What is the purpose we are using a different Kubernetes for a different virtual machine?
Kubernetes is an orchestrator that will run the containers, right? The orchestrator can only facilitate running a pod, but the pod is still dependent on the Docker file, and the Docker file is dependent on the image, which image you want to run, whether it's a Linux image or a Windows image. So you might want to have one orchestrator dealing with all your Windows nodes, another orchestrator dealing with all your Linux nodes, because you can register the Kubernetes. Kubernetes can have multiple nodes, right? The nodes themselves we need to figure out which node can handle a Windows pod, which which node can handle a Linux part. That's why I told you can have multiple installations of Kubernetes to manage different part. But Kubernetes doesn't care really. As long as that node is capable of running a Windows part, it'll know its capability and it'll deploy it there.
Okay, sir. Thank you very much, sir.
Thank you, Nandini. Good questions.
Hi, Raja.
Hi.
Raja.
Lata.
Hi, Lata.
Hi, how are you?
I'm doing good. Lata, can you please, you're using a headphone, right? Can you please increase the volume and come closer to the microphone and talk, please?
Okay, I'm not using
Yeah, I'm able to hear you now. You're better.
Can
Please
you
go
able
ahead.
to hear me now? Okay.
It's better. Yeah, please go ahead.
Okay. Can I able to deploy a machine learning model using Docker in cloud platform? A machine
learning platform?
Machine learning model
Yeah.
on.
Yeah, see, as you can turn any application into a containerized application. It can be a command line application, a desktop application, it can be a server, client server application. As far as you can see, sometimes many people misunderstand that my application, all the application has to live in a single container. It's not required, Lata. For example, you could have 10 containers and those 10 containers could constitute your machine learning platform. You could still deploy all 10 of them and make them talk to each other and have your application run. You can do that.
So it could be able to run in a cloud Azure or Amazon, anything else.
The beauty is you could have some of them run on your local computer, some of them on Amazon, some of them on Azure. As long as the Kubernetes, you provide the Kubernetes configuration correctly, the Kubernetes will figure out what pod to run where. You could put all your, you could dictate Kubernetes to run everything on your local network or on your local premise, on-premise, or you can tell, I want these parts be running on Azure, those two parts running on Amazon, and others run on my local data center. The orchestrator will figure out. It'll be able to smoothly run, and it can consolidate the results back and then give you an interface.
So everything is carried out by Kubernetes.
Kubernetes just launches the pod and the pod runs application logic. And how you use that is whether it's a web interface or a command line interface. Sometimes certain apps could be like a background job, right? You run some application, it computes something, and then it writes something onto the disk, and then it is done. You gather that file, and then you get the results. It depends on what your application does.
Okay. Thank you very much, Raja. It's a good presentation. Thank you for Professor Ravimaran.
Hey, Lata, thank you so much for attending the session, and that's a great question.
Thank you, madam. Thank you, Lata. Raja, last question from my side.
Go ahead, Ravimaran.
Last question. Okay, so with that,
sure.
we will complete the session. Okay. So can we run all the containers, created containers on the top of the edge computing? Is it possible?
Can you define that? Can you rephrase the question?
Because normally when you create a container, this container is running on the cloud, right?
No. Containers are, you can always tell where the container can run. It doesn't have to be, the container itself doesn't care where it runs. For example, you saw a minute ago, I pulled a container, I ran it, right? That container was running on my local laptop.
Any local machine or in the cloud. It is
exactly. You can dictate. I don't even have to run this command here. I can tell that run the container. I can connect to my Azure Kubernetes service. I can tell run this container. It will run in the cloud, but I can access it from my local laptop.
Okay. So is it possible on running on any platform? It's not
any platform. One more thing also, Ravimaran. Well, if you noticed it, I told you that you can. Let's say, for example, you run your web application in Amazon cloud, right? You can run a command from your computer. It will spin the container on the cloud, and it will run the application because you're going to access the application using HTTP protocol, right? You'll go to the browser and access it. Let's say, for example, you really want to go inside that container, you could use a shell, you could remote into that, you could telnet into that actual shell itself inside the container, and you can run inside, you can run a command, you'll be technically telnetting into that session if it's a command line application. But if it's not a command line application, if it's a web application, once you launch it, you're going to access everything from the browser.
Okay. Thanks for.
So you have the flexibility. You can go into the inside the container, or you can run an application and access it from a browser. Depending on the type of the application, you have access to go inside, or you can access it from outside.
Thank you, Raja. So now we'll close the session with the vote of thanks. And I request our Secretary, Chairman of CSA Trichirappalli Chapter, Mr. Selvaraj, to propose the vote of thanks. Sir, please, sir.
Yes, sir. Am I audible, sir?
Yeah, clear, sir.
Okay, sir. Thank you. Happy good morning to everyone. Happy good evening to Mr. Rajamani. Very glad to propose vote of thanks for today's webinar. I thank Mr. M. Raja, Vice President of Engineering, TransPerfect, Cupertino, California, USA, for an excellent, wonderful, emerging technology of the present time talk. Sir, we enjoyed your talk. Sir, thank you very much, sir.
Thank you. It's a pleasure talking to you guys. It's a pleasure presenting it to you guys.
Yes, sir. Thank you very much. Thank you very much, sir, for sharing your valuable experience on container technology with us. That is from virtual machines to container technology, which are the next revolution in virtualization. Container is a standardized unit of software Docker. That is, container is an isolated, lightweight, so running an application on top of the host operating system. You have very nicely demonstrated how container technology is far superior to the present VM technology. How the Docker and Kubernetes over the container technology, which are very lightweight and operational efficiency improvement. Thank you, sir, very much for enlightening all of us in container, Docker, and Kubernetes emerging technologies. We enjoyed your lecture, sir. Thank you.
Thank you so much.
Dr. Nizam Mohammed, Secretary Correspondent of M.A.M. College of Engineering, for supporting and guiding us to conduct today's program about container technology. Thank you, sir, for your felicitation about the webinar. I thank Dr. Ilango, HOD Computer Science, M.A.M. College of Engineering, for welcoming the gathering and introduce the speaker, Mr. Rajamani, to the audience. I thank Dr. S. Ravimaran, who is the person behind this today's webinar, M.A.M. College of Engineering, and our past chairman of Computer System of India, Untitled Chapter, for arranging the latest technology of container technology and conducting the proceeding as a master of ceremony of today's webinar. Thank you, sir. I thank all the professors, assistant professors, faculties, and staff students of M.A.M. College of Engineering for their participation. I thank all the members of Computer System of India, Trichirappalli Chapter, for their participation in today's webinar. I thank all the invitees for their participation. Thank you, Anand. Thank you, sir. Thank you,
sir. Thank you, Raja. Thanks for your wonderful support.
Thank you, Ravi. It's a pleasure. It's a pleasure meeting you. It's a pleasure meeting the CSA chapter members and your college colleagues and students. You all have a good day. I will sign off. Talk to you guys later. Bye.
Bye.